So Thorstein, we'll now talk about real life. Please go ahead.
Thank you. My name is Thorstein Thorsteinsson, and I'm neither a physicist nor astronomer nor biologist and glaciologist. And I guess the reason I'm here is that I became involved in this US-led project, pilot project, carried out in summer of 2002 to sample the Grimsvötn subglacial lake and study the biology in those samples. There are not so many places on the earth where subglacial lakes exist. The best known ones in Antarctica and in Iceland. And of course, Lake Vostok springs to mind right away. The best known and the largest one. You can see the flat surface of the East Antarctic ice sheet directly above the lake. And Lake Vostok, the Russian station, is at one end of the lake. And when the Russian drilling group drilled through 400,000 years of climate history, they entered into ice that had become accreted from below. This ice has been studied and people have found microbes present in it, and this of course ties in with the whole interest in sampling the lake and studying the microbial life that could be thriving there. I have not followed the developments of those plants very closely for the last 2 years, but my impression is that it will not be done during this decade, probably, at least not in a way that people want to do it. And this, of course, also ties in with the, or looming in the background, we can say, is the discussion of possible subglacial lakes beneath the polar ice caps on Mars, and the discussion of the ocean beneath the ice cover of Europa. If we take a look down on the North Polar ice cap on Mars, there has been in the literature, at least up to now, some discussion on the possibility that there could be subglacial bodies beneath the North Polar cap. This is the between latitude 70 and minus 70, and this is the North Polar cap. This is the entrant Casma Boreale. And there have been theories in the literature of this Casma being formed in huge catastrophic floods coming from subglacial lakes. Now, Iceland has plenty of such phenomena. Here's just a brief overview showing you the location of the main volcanic zone that runs through the country. Mid-Atlantic ridge comes ashore here, continues to the north. This is what defines the geology of Iceland, together with the fact that there is upwelling material at the so-called hotspot location. So you get all the rocks to the west and to the east, and the age is effectively zero some places here in the center. The center of upwelling is beneath the northwest part of the Vatnajökull ice cap. And that is where we have all these interesting phenomena, like subglacial lake Grimsvötn. We will be focusing mainly on here. These dots show the sites where meltwater can collect in depressions at the glacier bed. There are 5 or 6 subglacial lakes known beneath Vatnajökull at the present time. And here is a satellite photo showing the Vatnajökull ice cap.
How thick is the ice?
Yeah, the area of Vatnajökull is 8,000 square kilometers. It is a temperate ice cap, one of the largest masses of temperate ice on Earth. The maximum thickness is about 1 kilometer, average is about 500 meters or so. It's quite dynamic, it's temperate, it's at the melting point throughout. And you can see here, this is an ice-filled volcanic caldera, 2,000 meters elevation here, quite flat. Within the rim, the surface within the rims of the caldera. Another one up here. This is the Grimsvötn depression here, where the water collects and comes out in these catastrophic floods that occur occasionally here in the south. There are also flooding. There is also flooding occurring every 2 years or so from these small cauldrons here to the west. And we can expect things to tend to break loose in this region at any time. Yes, I just went a little bit ahead of myself here. Ice caps cover 10% of the area of Iceland. 60% of that ice overlies the volcanic zone. So that creates all these strange phenomena. We had this number of glacial eruptions in the 20th century, and we have these strange formations formed in volcanic eruptions beneath the ice cap that covers the country during the ice age. And we have canyon lands in Iceland formed in catastrophic floods from the ice caps, and these phenomena are under active study now by several researchers studying similar phenomena on Mars. Here is just see the photo in the center. It's a view of the Grímsvötn depression from the northwest, and this is the location where we did those ice core and thermal drillings into and through the ice shelf that I will be telling you a little bit more about now.
Question: How do you detect these subglacial lakes without drilling?
Well, people have witnessed these floods coming from these regions for centuries, really. So they have just got to know that they are there, and you can see that the whole area subsides when the water escapes. You need the water to get up to a certain level before it can float the ice and then escape beneath the glacier. Then the whole area sinks and breaks up, so you know it's there, it must be there.
So you detect it indirectly.
Yeah,
it's the same on Mars. You have to see the floods to be able to.
Yeah, that's right. Grímsvötn is the most active volcano in the country. Eruptions occurring on the average once every 10 years. These are just some basic figures about the ice shelf covering the subglacial lake, thickness of the shelf and things like that, the lake depth. And there is continuous geothermal activity from beneath, sustaining this lake, melting the ice continuously, and in addition, surface meltwater is seeping down through and taking part in sort of contributing to the water that is collecting down there. And then these are typical volumes that are emptied out in these jökulhlaups, as they are called, or catastrophic floods. Periodicity and the size varies with the level of geothermal activity, which is ever changing. And most people probably remember this huge flood in the Gjáll volcano in 1986, which filled the depression completely and resulted in a catastrophic flood.
Was that where some of the bridges were?
Yeah, that's right. So I will tell you first a little bit about the ice core drilling project that was carried out from the ice shelf in 2002. I've been involved in the building up facilities and experience in Iceland for ice core drilling in the last few years. I just want to tell you a little bit about that. We were testing a new system for drilling in temperate ice. We were trying to find out if we could detect annual layers within the ice shelf. That is, of course, extremely important in all kinds of ice core studies to date the ice core as thoroughly as possible. And we were interested in estimating the input of dust originating in the nearby deserts surrounding the ice cap. It's blown into the ice cap. If we know approximately how much is in the ice on average, then we can estimate how much goes into the lake over a certain period of time. And then we can speculate, are there microorganisms attached to the dust particles that are transported to the lake in that way, first up on the ice, then 200 years it takes to go through the ice into the lake. And I should mention that the microorganisms that have been observed in the Vostok core, it's not completely certain that it is not contamination, but still, they were usually attached to dust particles of this kind. Sorry. Here is what it looks like in the upper few meters. We were there in the summer of 2002, and at 4 meters depth, we entered the tephra layer that was deposited in 1998. And it's interesting for the sake that it's telling us that we lost the entire accumulation of 2 years, 1999 and to summer ablation due to the deposition of this tephra layer. The solar heating of the tephra grains is so effective in melting the snow that we lose total accumulation for 2 years. At about 20 meters depth, our temperate ice mass has transported into what we call glacier ice. That is where the passageways in the firn have become sealed off to form air bubbles. Very important in the study of old atmospheres in polar ice studies. This process takes 200 years in Greenland at minus 30 degrees. It takes 3,000 years in East Atlantic at minus 55 degrees. Here it takes 10 years or so at the much higher temperatures. And just deeper down, some other interesting phenomena to study. The ice is very bubbly when it has turned into glacier ice, so milky looking, but there are these occasional completely bubble-free layers formed probably by melting, refreezing processes close to the surface. So we are learning a lot about the sort of internal structure of temperate ice in these studies. We did 150 million core in 9 days, and to answer these questions here, can we detect the other layers, like in another core that we drilled on the off-circuit ice cap? Am I finished with my time? Okay, this is another ice cap, not so far away, and you can see here's another ice-filled volcanic caldera beneath that ice cap, and this site turned out to be a very successful one. We see that, sorry for the bad quality of this, we have about 33 years of precipitation here, and we get a regular dust peak deposited on the ice cap in almost every summer, and we have these occasional volcanic tephra layers helping us to constrain this state. And the question was, would we see the same in the Greenfoot core? But it turned out definitely not to be so due to excessive summer meltdown. This is just briefly about the dust particles, what they look like. This is basaltic crystalline material, up to 50 microns or so in size. Just to give you an idea of what it looks like, but we have not seen anything that looks like a microorganism in any of these images. Our dust profile from the try to do it as clean as possible, but it's not easy, definitely not. It's a big concern. And this is a picture from the sampling procedure.
Is he sucking up the one?
It looks like it. He's just holding it like this. It's a counter, step counter. The thermal drain was used to penetrate this ice shelf in 6 days. There was only 20 meters of water depth beneath the ice shelf at that time. It's usually about 100, 150, but most of it has drained away shortly before we came there. They took samples for chemistry and biology from the surface snow, from the ice core that was just drilled on the same site, from borehole water before penetrating into the lake, after penetrating into the lake, from the subglacial lake waters, and from tephra and dust sediments at the bottom of the lake. And then they performed analysis on these samples. And I'm not going to say that I know much about this or can describe it in any good detail. But this is just a short overview over the main results. The lake water is at the melting point throughout. It's dominated by glacial melt. There's little input from the volcano, at least at present. Microbes were found in all the samples. The highest cell counts, they just count cells per milliliter in a sample, in a liquid sample, and cells per gram of a tephra sample or sediment sample from the bottom. Was by far the highest count in the bottom sediment. In the lake samples, it was something like maybe 100, 200 cells per milliliter, or something like that. Culturing experiments at 5 degrees Celsius, actually higher than the temperature of the lake, showed the cell growth in samples from the subglacial lake, not in samples from the ice in the ice shelf. They conclude that there are psychophilic organisms present in the lake. They did this molecular fingerprinting of microbial communities, and that looks like this. Lake and sediment communities, sure you're all familiar with these bands that really don't mean anything, but the comparison between them means really something. You can see that the lake sample and the borehole after the lake sample had sort of gushed up to the borehole give very similar patterns, whereas the lake and the borehole before penetration are different. And the lake and sediment communities are distinct from snow communities. Jacuzzi was a geothermal lagoon at the edge of the glacier, so separated from the surface. Back to this, and then finally uptake of Z14 lagoon bicarbonate in dark incubations of lake and pepper samples took place, indicating chemoautotrophism, that is, that these are organisms that have to rely on chemical processes for powering the biology. And I think that's it. But there, of course, are skeptical voices from viewers of a paper that has been submitted on this. Matching close to Herbacterium bacteria, there's a specter of contamination inside from the diesel fuel drilling machinery, and there are numerous problems that we review as time in culture and incubation experiments. Jury is still out on this, but we will see. If further work becomes funded, we will carry out a 4-year program to do further sampling in Grímsvötn and cauldrons west of Grímsvötn, but are much better isolated from the atmosphere than Grímsvötn is. The ice shelf is breaking up all the time because it's close to the atmosphere occasionally. These cauldrons are in the 500-meter thick ice, much better sort of isolated from the atmosphere. But definitely these are not 15 systems like Lake Vostok has been isolated from the atmosphere for millions of years. It's a different thing. We aim for core drilling on the Varabunga plateau and rock drilling into the recently directed circulation volcano Gjár, studying the effect of microbes on operation in this material, something that has been recently observed. And that's it, and thank you for your attention. Thank you.
Yep.
Did you ever try culturing experiments at high temperatures and 5 degrees Celsius? Did you think that there would be thermophiles of the temperatures?
I know that they concluded that there were no thermophiles in the lake. I don't know if they did any cultural experiments at high temperatures.
Anja?
So could one conclude that you actually find some of the descendants of things feeling that life actually developing cracks and
I think it's too early.
What about oxygen in the lake?
Yeah, that's a good point. There are no measurements of that yet, but that's definitely something that we have to do.
Growth experiments, were they done with oxygen? The growth experiments, cultivation experiments, were they done in presence of oxygen?
I don't know, I'm sorry.
Okay. What about pressure? What's the pressure of that?
It is 30 bars.
But doesn't account for the weight of the lake?
For what?
For the weight of the lake?
What does it account for?
30 bars comes from the weight.
Yeah.
That comes from
Yeah.
the weight.
Oh, yeah, what?
Yeah.
And then what's the temperature? 90 degrees, is that all?
No,
No.
zero, or maybe slightly below zero to the depression. Nothing possible.
Could I just ask a slightly further question? Tell me, if there was one of the yodelers when you were there on top, would you be in danger of joining your microbes? What would happen? Is it not a dangerous experiment?
Yes, that's right. This is the ice shelf here. This is where we are working now. It would not be nice if our volcanic production started when we were working there, because the volcano is just a couple of kilometers away.
Well, you're very involved, in fact.
There will be time to get away with the sea speed. But there's a hut here, 3 meters away. Pretty safe place to be, unless the hell completely explodes.
Then you don't want to be nice.
So you're really quite ironic that you've been interested in this work.
Do you have any data or estimates of the magnitude of growth in the lake water?
You mean also the missing and
The speed of the
no, we have nothing on that, but we are planning to start to work on that here in summer.
Yes, Ian?
So were these microbes, were they any different from microbes that already known?
They compared with these gene banks or whatever, go to some comparative DMC, all kinds of microbes from everywhere. The bottom line seems to be that there was a lot of stuff that was simply closely related to soil bacteria. And then the reasoning is maybe this is originating in the Icelandic soils, the interior of Iceland, and transported with the dust particles to the ice cap, goes through the ice into the subglacial lake. But this is sort of a working hypothesis. But there was not only that, there was also other stuff.
And also, you could not detect any spores or any bacteria in the dust when you looked at it.
No, but they have not looked at many samples really from that. This is one thing that they are really interested in.
Yes, one question.
When you have this runoff episode, don't you get cracks in the ice field that could introduce contamination?
I think this combination issue will be one that we may need to discuss during the discussion. I mean, this combination is a very general problem which we are dealing with, or sort of in connection with studies of life on any other extraterrestrial body. So it's very important. I think we may come back to that in the discussion. So thanks for the speakers of this morning. We will have lunch now. Lunch is in the NPI cantina. Please follow those who know that. And your name.
And